All right, welcome everybody to class 4 of the Cloud Solutions and API Integrations class. I'm the professor, instructor Jeremy Bergman for Omaha Data Science Academy, and class 4 is about data processing in the cloud. Right. So this class is structured, hour 1, a lot like the other classes. It's an overview. This one will be particularly of cloud-based data processing services. This focuses on the Azure cloud-based data processing services. So this will include Azure Data Factory, Stream Analytics, HD Insight, and it'll also include an initial overview of Synapse Analytics. Hour 2 will be a deeper dive, is what we'll go into today is serverless data processing using Azure Data Factory. As far as what I use the most out of Azure, Data Factory is probably the service that I use the most. This is really useful for just connecting to different data sources or connecting to different REST APIs or different network connections, FTPs. There's all sorts of things that you can connect to through Azure Data Factory, and it helps with like the movement and transformation of data. And we're going to see that today, how that works. And that's just, as a data engineer, is one of the biggest part of my job. It's just like extracting and organizing and moving data is like its own huge task. Like every day for a data warehouse, or even now like every hour, almost near real time, or even with Azure you can do it real time. Then hour 3 we're going to go hands-on. It'll be a rather lengthy hands-on exercise with Data Factory pipeline. We're going to create a pipeline that connects the data lake, those CSV files that we were working with on Monday, and we're going to load those CSV files into the MySQL database table inside of your schemas that we've created. All right, so excited to get this started. Class 4 objectives. What we'll cover in this class is, as I said, the first hour's overview of the cloud-based data processing services. We'll cover those 4 services. In Azure Data Factory, we'll abbreviate that as ADF. That's what Microsoft often does. We'll go into a deep dive of this because this is really like the heavy-duty CERD data movement and management service I was talking about. So we'll just cover first like when you'll use this, the real-life applications that you'll use it. You'll use it in almost nearly every process or pipeline that you create, or data pipeline, or what's the other word? Data process or data pipeline you create, whether it's for like advanced analytics, it's for big data, or it's for just regular business, day-to-day business intelligence and reporting. You'll use Azure Data Factory in nearly all of those, or have the opportunity to. We'll go through those core components and do a demonstration of it. I have a video that somebody does a really nice job of walking through Azure Data Factory. And then we will also review monitoring and pipeline management. So part of an engineer's job is, of course, when things break, is to be able to be on top of it and fix it and monitor it and be alerted to it and create alerts for it. And then managing pipelines for performance. So making sure like the data is flowing optimally or the systems are working optimally. So we will cover that as it's a big part of data, not just data, Azure Data Factory, but also being a data engineer and doing those things as part of your job and making it easier. All right. So what are cloud processing services? We always start by opening it up with a definition or saying what are these things. So this is one of the main parts of the cloud data infrastructure that we talked about is the data processing. We did data storage last time, doing data processing today. So data processing service enable the collection, processing, analysis, and management of data in scalable cloud environment. So these services are designed to handle a wide range of data workloads from batch processing to real-time data streaming. And we have a few examples of this. Your batch processing is like that day-to-day that I'm talking about. You're just taking massive amounts of data from different sources or systems, and you are transforming it in a way that you need for reporting and analytics. So we use the acronyms ETL or ELT, mentioned those a couple times and do that a little bit in the SQL class, is that you're extracting it from systems and then you're transforming the data and loading it into usually a database or for some other analytical purposes. And then the data lake also allows you to do extract, load, and transform. So we talked about that with the data lake, as that's becoming really popular, is loading the data there and doing the transforms later. The Azure data processing services actually make this really attractive, ELT really attractive. You can do both, but particularly with data lake and these processing services, just loading the data and then creating pipelines for all the transformations you need can be really quick in Azure. All right. So data integration services, there are a ton of different connectors and that you can use for the movement of data via pipelines. Just briefly mentioned that in the last slide. There are all sorts of different kinds of connectors to databases, web APIs, other Azure services, FTP, almost anything that you can think of that helps with that whole extraction and movement of data, which is a big task for data engineers. Big data analytics, so high volume and velocity data. We saw some big data analytics storage technologies as far as those databases, the processing of high volume or high velocity data. So high volume is just huge amounts of data. Think of like your millions of transactions per day and your credit card transactions. Or sometimes this is even velocity of data. So if you think of like streaming music or something, literally like it's megabytes per second that you're trying to process. So high velocity or high volume data. There are also technologies for that. And then real-time data streaming. So we'll do an example of this. There are a number of real-time data streaming use cases, but the cloud helps you do that. So specifically Azure data processing services. For batch processing, it's Azure Data Factory. For real-time processing, Azure Stream Analytics. And for big data processing, it's HD Insight. So tools that are made for each one of these different cases of data. And as an engineer, being familiar with them and knowing they exist and what they're used for and what they can be applied to is big. All right, so and specifically cloud data processing and the data engineering hierarchy of skills, it would really cover especially number 2 and 4, distributed processing and streaming. So some of these technologies allow you to take a big workload and break it into smaller pieces so you can process it faster. And it allows you to do ELT and ETL into data lakes, warehouses, queues and pools and stuff like that. And then to some degree, helps with DevOps too, being able to develop the right solutions. So this is where we're focused on with this lecture. in the data engineering hierarchy of skills. I'm still not sure what that question mark is. I looked at that today, and I think that's like the profit at the end, you profit or something like that. You have the lower steps, and then you have question mark, profit. I think that's a data engineer's job. I guess number one would be everything above that. But maybe it's deployment and creating the solution. I guess that's what I'll call it. But you can see where these processing technologies help out with the solutions that engineers create, data engineers create. Okay. So use cases, cloud-based data processing. This is kind of like getting familiar with all of these things that we talked about, but also sort of like the why. Like, why is cloud-based data processing important? So important for data warehousing and analytics. So data factory and your databases and being able to store historical information and business rules. That is really valuable for businesses. So cloud-based data processing service make it efficient for data warehouse and data storage and analysis. So log processing and analysis, this is probably closer to like your big data or your huge volumes. If you think about logs that systems create, it's usually huge amounts of data. Sometimes you want to process them, sometimes near real time. You can leverage the cloud-based services to handle those large volumes of log data and extract valuable insights. Some of the tools will allow you to do those in basically real time, which can create a huge advantage. Genomic data analysis is one. So genomic data is also big data because human genomes are huge, but employing some of the information in the genomes is huge, and being able to process, that's one of the big like scientific computing areas of that's been a challenge for a while. So employing cloud-based data processing for advanced analysis of genomic data enables breakthroughs for healthcare and research. So now they're talking about, AI is like one of the biggest areas is in healthcare and, diagnosis and just in general being able to smart, intelligent robots and things like that. But, being able to research genomes in a much more efficient manner is the underneath of it, being able just to be able to process all that information is data engineer's job. And then you add AI and the new insights on top of it. There's just breakthroughs and makes it for breakthroughs in healthcare. So the combination of computing and cloud power along with AI is huge in healthcare. So real-time event processing. So harnessing the cloud to respond to real-time events with speed and accuracy. One of the ones that I like, one of the use cases that I like that we'll bring up here in the first hour, it's for supply chain, looking at inventory. So oftentimes, as somebody will quickly buy up inventory, and you often may not know about that until the next day or sometimes later. But if you have real-time event processing on your inventory, you could potentially alert yourself to something that's gone out of stock, and then maybe you offer a different product in its place, or you do some type of other action in real time to try to help manage your inventory. So being a supply in my background, one of my highlight strength, the industry that I like the most, that I've done the most analytics in is supply chain. So seeing the value, I can definitely see the value in that as far as real-time processing. And then of course now cloud-based data processing unlocks a lot as far as machine learning and AI applications. So one of the big ones is Tesla and the self-driving cars. Well, basically how that works is like they collect billions of data points from sensors Um, whether it's like Google Maps information or sensors on the car, they try to collect that data, and then they try to do real-time insight for the car to be able to recognize certain situations or stop signs and things like that. So it's massively intensive as far as that data collection and analyzing all those solutions. AI and now cloud-based helps create those models and drive innovation in AI applications. So another one of them is actually ChatGPT. And I don't know if anybody watches like business news or anything like that, but they actually the chip companies like NVIDIA or the product companies that create these processors, they're always running out because there's just a huge race for people to have more and more computing power and those resources at hand. That's because there's so much data to crunch that like the more data that you can get and you can crunch with these in these AI applications or something like that, or machine learning in general, the better your models will be and the better the performance will be. So especially with generative AI, it's just like a race for computing power and chips and resources. But cloud is a huge part of that. So Microsoft recently partnered with ChatGPT, which gives them leverage on some of the computing resources also. So a little bit of a tangent, but showing why like all this cloud-based data processing is important. It's important for really a number of reasons. That some of the neater ones are, the generative AI and the machine learning, and I think the AI and health breakthrough and healthcare and research AI is the AI and healthcare and research is huge too. Being able to generate those new insights and predictive models and AIs that help with diagnosis based on genomic data that people have never been able to do before. I find it really exciting, and as a data engineer, you get to be a huge part in engineering those solutions. All right. So I found some best practices on implementing cloud data processing services. And I really like these because it makes you think like a data engineer. So you have understanding data processing requirements, leveraging the managed services in the cloud, implementing security. We don't cover it a lot in this class, but security is important when you consider data. So especially like sensitive data and what you do with it. Optimization. So optimizing your configurations or your data pipelines, and then regularly monitoring and optimizing data processing workflows. We'll cover that more in class today. Talk about how important it is, and that Azure Data Factory has some of those capabilities to both monitor you and alert you to things. I would say that this is like covers pretty well what the responsibilities of a data engineer are, especially related to cloud computing. So for understanding the processing requirements, being able to understand the processing needs and select the appropriate cloud-based service, such as Azure HD Insight. So why I cover a lot in this class is that, so at least like some of the stuff that we don't cover as far in depth, at least you're familiar with it and you potentially be able to pick it as a solution if the right use case and the data processing need or the storage need or the analytical need would come along. So I think it's important for engineers just to know what's available so that they can create the best solutions. Leveraging managed services is really like managing the cloud feature, the managed features, to minimize the operational burden and focus on data processing tasks. That's probably one of the biggest things about going to the cloud, is because now you don't have to even manage all this hardware or these configurations. Now it's configured for you. You can focus more of your work on data engineering. So particularly for data engineering, like having managed services, I believe, is huge. So you don't spend your time just managing a database or managing like a Hadoop cluster or something like that. Implementing security, having robust security measures to safeguard sensitive data and the transfer within cloud environment. You're just oftentimes moving a ton of data, especially important in healthcare, like healthcare records or PHI, personally identifiable information. I didn't do that right, but anyway, moving that type of information, that's like, even to do that, you need to have it secure and locked down and encrypted when you send it across email, or you open yourself up to like major lawsuits. A data engineer can help implement those. Optimization, you can do quite a bit of that within Azure, and then monitoring your workflows, as we talked about. Okay. So all considerations when you are a data engineer, and some of the best practices for when you're engineering a new solution. All right. So now we're going to cover at a high level the four data processing services that we talked about. So what is Azure Stream Analytics? So Azure Stream Analytics is the real-time event processing service, enable ingest, processing, and analysis of streaming data in real time. So that's quite a bit, but it helps with, in the first part, ingest is just bring that into the Azure data ecosystem and into Stream Analytics, being able to process it real time. And then one of the most impressive parts is being able to analyze it in real time also, or near real time, using different queries. The video is not appearing here, but we will watch this video here in a minute. It'll give you an example of how you can create this process in real time. So use cases for Stream Analytics is IoT data. So the example I give about Tesla and collecting all those millions of data points, those are really Internet of Things data. It's like different sensors collecting data in near real time. You can use Azure IoT Hub to be able to ingest those, process, and analyze it in real time, potentially even for AI type applications. So predictive maintenance is one of the big use cases. So somebody I work with, they actually do this. I don't know if they do it through Azure or not, but they do have predictive, like real-time predictive models. He works for Airlight Plastics. So I don't know if anybody's ever heard of Airlight Plastics, but they have a ton of machinery that creates all these different plastic containers. Based on like temperature, how old they are, or certain maintenance schedules, you can predict like when these things are going to fail. The closer to real time that you can do that, the more problems that you can avoid in the future. So like if you can tell like a machine's overheating in real time, you can shut it down and do maintenance on that. Or like if it hits certain thresholds or conditions. Being able to do that in real time with the type of equipment they have, they could save you millions of dollars. Sometimes like if you didn't have that, then potentially you wouldn't know it, and then it would run like that for days or weeks and then eventually break down on you. So that's one of the big use cases of it, and I know somebody's implemented that. Log and event monitoring, so really important for applications and systems and like performance. Sometimes they detect issues and respond promptly. One of them is e-commerce. If like your system is down, being able to do that, detect it in real time and respond appropriately. And then supply chain optimization is the one I talked about. The use case for that is real-time inventory analysis. And there are all sorts of like little things that you can do in real time. I'm sure that Amazon already does, but maybe the smaller guys don't do quite as much. So I want to bring up this video. Oh, there's a video when I pull it out here of real time, or I mean, when I pull it out of the slideshow mode. Let me at least get the link here. If I can't play it, actually have a little bit of a trick. I did this in PowerPoint first. I'll pull it out of the PowerPoint presentation. But I want to show everyone how this works. I haven't used it really the real time myself, but the use cases are definitely there as far as being able to do real time analysis, and this type of service being able to make that more realistic. So I'm going to bring this worked when I played it out of a PowerPoint today. Of course, when I get here, it doesn't work quite as well.
Welcome to Azure Tips and Tricks.
I'm going to pause it for half a second so I can get this link and put it in the browser if I can. Copy link. There we go. Almost panicked, but don't need to do that. Okay. And I want to switch over to this other connection. I might lose everyone for half a second on this feed, but I'm going to switch over to this hub that I have to see if it helps with the video streaming at all. So 1 minute while I do that. If I lose you, I'll be back on in just a minute. Jen's going to give that a try. Okay. Am I still with everyone? Everybody can hear me on the feed? Okay. Let's see if this works better at this video stream. Okay. Let's see if this works better. This connection works better when I'm streaming the video. So we're going to start. It's a 4-minute video, but it's like a really good demo on how you use the Stream Analytics. And this is an example with Internet of Things, I think. Can everyone hear that online?
No.
Yeah. Give me a second. How did we do this last time? Oh, you know what? I remember. So we have to make this its own like specific window. Okay, so stop. Present. Now that I know all of the quirks of StreamYard, hopefully Nate never changes it. I don't know. He'll throw me for a wrench, I think. Okay, now I'm focused on this specific window. I'm going to play it and let me know if you can hear it.
To query streaming data.
Yes.
We will use a relatively complex setup with various components. The Raspberry Pi simulator will generate data for us, which we will ingest with Azure IoT Hub.
Is it coming over loud and clear?
Good enough. For me, at least.
Yeah, it works for me.
Working? Okay, that's awesome. All right, I'll let this play.
Azure Stream Analytics will get the data from Azure IoT Hub, query it and transform it, and send the results to Azure Storage. Let's start by creating an Azure IoT Hub. First, I'll select a resource group and now give the hub a name, like this.
So
Okay,
how you
I'll leave the rest as it is and create. And I'll skip to when it is done. Here is the IoT Hub. To be able to ingest data, it needs a device to connect with it. So here, let's create one. All right. Enter a name for the device, and that's it. This device is the digital representation of a real-world device that we connect later. To do that, I need this connection string. Okay, let's move on. IoT Hub serves as the input for Stream Analytics. And when the data is queried, it will be put somewhere in a new Azure Storage account. Okay, again, let's pick the resource group and also enter a name for the account, like this. And I'll leave the rest and create it. And again, I'll skip ahead. Here is the storage account. Stream Analytics will write blob files, so it will need a blob container for that. Let's create a new one. I'll keep the name very simple. And I also leave the access level to private. Okay, create a container, and that's it. We need to create one final thing, the Stream Analytics job. This is the thing that will query the data stream. All right, let's give the job a name. And I'll pick a resource group. And I'll pick the same location as the other services are in, so that they are close together and work fast. The hosting engine should be cloud, because we run this in the Azure cloud. Also, these are enough streaming units. You can scale this up if you need more power to process the data stream. Okay, create it, and I'll skip to when it is done. Here is the Stream Analytics job. Let's tie everything together. This job needs an input and an output. Let's add an input first, and that will be the IoT Hub. Okay, I'll give the input a name. That should be it. It already selected the hub that we created earlier. Perfect, that's it. Now for the output. Let's add a new output. And this will be a blob storage output. All right. I will also give this one a name. Okay. And I need to pick the storage account that we just created. Here it is. And this is the right container as well. I'll leave the authentication mode to work with a managed identity. That should work automatically. Save it, and that's it. Now for the query. This is the query that analyzes the real-time data stream. I'll change it into this. These are the names for the input and output. And it will query for data that contains a temperature above 27. This job is complete. It has an input, an output, and a query. Now we need to start it. That should be it. And here is the Raspberry Pi online simulator. You can find the link to this in the video description. This needs to connect to IoT Hub. I can do that by replacing this line with the device connection string that we copied earlier. Now run the simulator, and it is sending messages. Cool. These come into the Stream Analytics job and will be queried. And they should be outputted here in Azure Storage. Let's take a look. This JSON file is the result of the Stream Analytics query, and it only contains messages of temperature data above 27. Cool. Azure Stream Analytics is great for querying streaming data to reveal relevant information. Go and check it out.
Right. I thought that's actually an awesome demo of one of the use cases. So keep in mind, it's not just for Internet of Things data. So as long as you have like a streaming input, a query, and then an output, you can use streaming analytics on different things or events. So the most useful on the high velocity data that we talked about are things that you need to do in near real time. So Internet of Things is a perfect example. So that Raspberry Pi, it's basically like a little board that you can program to do certain things. One of them I know is like you can create like a video game console controller out of it, and then it could sense buttons and things in real time. Internet of Things is like one of the best examples. Is like getting data off those sensors and being able to do things. But there are a number of applications for it also. And even the machinery example that I talked about, monitoring machinery, that'd be an Internet of Things type application because these machines will have different sensors on them, like temperature or, RPMs or whatever else they would model throughput. And that generates information that you could collect in stream analytics and analyze in real time. So pretty neat. Hopefully someday I know that someday I'll have an application for it. I haven't used it myself yet, but that day is coming, especially for like things that are more like real-time AI related or close to real-time AI related. So that's one of the technologies, the fancier technologies that I could definitely see use cases for and wanted to provide an example of it.
Hey, Jeremy.
Yeah.
One of the things I think I'm noticing, and maybe I'm wrong, is that with Azure, you've got all these things you got to name everywhere. So you set up this component, you got to name it, you got to set up this component. You end up with this whole block of these different types of components and everything. How do you organize all that? Do you like a diagram to show exactly what's connected to what, or is that still going to be an offline type of solution or something like that?
Well, resource groups will help a little bit with that, with organizing the resources.
I'm looking at it from more of like a whole company type of thing.
Yeah.
Like say you have a company and you've got 7 different projects going, and you've got all these different things in Azure. You got 450 servers. All these other things. It just looks to me like it gets complex quickly once you start scaling up.
I think high level design is a consideration, like just bringing in like I hate to pitch consultant here because that person wouldn't necessarily be me, but somebody who could look at your landscape and be like, hey, here's the best setup for you guys. You could actually save lots of money doing that. Like setting things up in the right regions or saving it under the right subscriptions or resource groups and how you organize all of those things.
Okay.
It's like its own big consideration because you could technically like go across subscriptions and connect to it. It could become a knotted ball quickly, right? You could imagine that.
Yes.
Like so when upfront thinking like forward about how you put together these resources and resource groups and like those logical blocks. And we didn't cover it a lot here, like in the first class, but hey, like reviewing like some of Microsoft's best practices and like how they think about grouping resources together would be a good approach. And if it's a big enough project, potentially like a Microsoft consultant or something, maybe to help you. It could potentially save you, like you were talking, John, like your bill was $1 million. Like, it could save you a couple $100,000, like by having the right configuration or like the considerations and everything like that. Does that answer your question?
Yeah, it does. Thank you.
Yep, you're welcome. That guy is not me right now, but they'd be out there. There's actually, I think within Microsoft, some of these apps I'm seeing more and more where you can request like experts and stuff like that. So either through Microsoft website or maybe, independent shops or other consultants like that. Something I should perhaps consider myself starting to do. Okay, back to the lecture. and share the right screen here. Back to slideshow. So I thought that was a pretty cool video doing even, so especially since I don't have a lot of experience with it, someone showing a real life use case and how that would be used. And basically that's what this graphic here is that you have the event producer, whether it's Internet of Things or some type of log or API data. You have your event processor where you can process and query real-time data in near real time. And then you can put it out to a consumer, whether it's like a Power BI dashboard or an application or alerts and email and things like that. Well, definitely some good applications here that you can do with real-time event data. All right. So we're going to move here to HD Insight. So this is going to look a lot similar to Cosmos DB. So Cosmos DB was like a suite of those different NoSQL storage technologies. Like HD Insight is basically the same thing, except it's for data. It's like data processing and a little bit of data storage, but mainly data processing technologies. It's kind of interesting with Microsoft. I'm not covering these a lot like HD Insight or Cosmos because Microsoft has really like their own version of these for the most part. So like Synapse Analytics is going to have Spark. It's not going to have Hadoop or some of these other like open source, special use case type things, but even Apache Kafka, this is like Apache framework, open source, HD Insight. We just saw real-time streaming analytics. So but interesting, so my point is interesting with Microsoft is basically they create one of these functions and then they have like a company that they bought like Databricks, or they bring in like Cosmos DB or HD Insight, which produces like the same thing as a proprietary solution, but it's like its own ecosystem. Same, my theory is like they compete head to head and then see which one's going to be adopted. But I'm not exactly sure why Microsoft does that, but that's why we don't focus on this quite as much, because I'm focusing on the Microsoft version of it. But it's also good to know that these things exist, and it's also an alternative. So HD Insight is basically that suite of technologies that's for improved data storage and big data processing. HD utilizes Hadoop for batch processing, Spark for in-memory processing. So Synapse Analytics also has Spark, which I use for big data sets. Kafka for real-time streaming capabilities, and HBase for NoSQL data service for large-scale applications. So the advantage to HD Insight is, like a lot of things in Azure, it's fully managed service. It supports an open source framework in Apache. Some people really like the open source technologies and knowing the nuts and bolts and things of the proprietary solutions. Secure access with Azure Active Directory, so it's integrated with the Microsoft security protocols, and comprehensive integration with Azure services. So not only is it these technologies, Microsoft's taken them and integrated it into the rest of like the Azure technology stack. And I know historically, before these cloud platforms exist, I was familiar with these and having used them myself, but they're extremely difficult to like configure and maintain themselves. It like takes really like specialized knowledge to learn how to like configure like Spark for distributed computing across multiple servers, and like keeping track of performance and making sure everything's right. and so forth. So these were like extremely difficult to configure themselves. But Microsoft has made it part of their integrated stack, and now it's fully managed and a lot more accessible for companies to use. So these are definitely known as like high performance technologies, maybe even better than the Microsoft versions, but they're both comparable to the Microsoft versions, and they're all integrated into the stack. I can't say that I prefer one over the other necessarily, like the HD Insight or the Cosmos to the Microsoft versions, but for the purpose of this class, I found it a little bit easier to teach Microsoft versions, and then you can learn more about these as your use case is needed. All right. Moving forward, so we're going to briefly introduce ourselves to Synapse Analytics in this class. The next class on Monday, we're going to start the deep dive into Synapse Analytics. So Synapse Analytics is really like a big data and data warehousing, processing and storage platform that's created by Microsoft. It combines big data and data warehousing solutions into a unified platform. It's integrated with various analytical capabilities, enabling businesses to scale and query and analyze their data at scale. So it provides a number of tools here. We'll go through the features first, and I'll explain this diagram. So the Synapse Analytics features integrated analytics for big data and data warehousing included in a single service. One of the things I use quite a bit for big data is Apache Spark. You can break a bigger data set and do distributed computing. Say instead of doing it on just one computer, you can break the task down and do it on 10 computers. So in theory, it's 10 times faster. Doesn't work quite like that, but the idea is that you can process it a lot faster and do a lot with Apache Spark and do more in-memory processing. You can do on-demand query processing using, you'll notice Data Explorer that we just used in the last class. Synapse Analytics also has Data Explorer integrated in, so you can do query processing in real time or near real time with that. It also has a managed SQL database. So you can do on-demand data warehousing with serverless SQL pools. So a serverless SQL pool, it's not a database that runs all the time. It's just a database that runs whenever you need it. So if you have a request from an application for data from the serverless SQL pool, it'll basically wake up the SQL pool to be able to get you back that data. Now, this is typically an expensive service because the processing power and the memory is high, but they make it serverless so you don't have to run it 24/7 and have the huge expense. You just do it on demand and when it's needed. So typically, I'll actually use, for the most part, I'll use a managed SQL Server instance that's outside of Synapse Analytics if I need something that's on more often and that's lower cost. But for certain specific analytical workloads, I use the on-demand SQL pool also if I need something that's high performance and I'm willing to pay a little bit more for that performance. It has Apache Spark integration. I do use that quite a bit. One of the good things is that you can use Jupyter Notebooks with this. So you can create Python code and then use some of the functionality of Spark and that syntax to be able to process big, huge sets of data that are in memory. So it's kind of like ETL or doing your own processing. You can use Spark and notebooks to write code to be able to do that.
So when you talk about big data, how big are you talking? How many rows of data? How complex are your data sets you're going against? Like table comparison wise, stuff like that.
Yeah, so big data is a good question. So I try to think of it as what are the limits that you hit with a relational database? Just being able to like load data into a relational database, and then processing's a big part, like queries and so forth. So I would say I usually start to have challenges just as a rule of thumb. If you start to get into the hundreds of millions of records, unless it's like a pretty narrow data set without very many columns. So that's when I'll start to break it down into, I'll do like a partition key and break it down by months or years or something, and then use Apache Spark to process it year by year and then bring it all back together.
So when you say you're processing it, like say year by year or something like that, you're running your machine language code against that section of the data?
Yeah. So you can apply functions and routines in Apache Spark. Say we will cover this a little bit more in the 7th lecture, like Apache Spark and how to do it. But that's the idea, is like, how do I break down this workload and apply like the functions I needed to like effectively process this, because the limitations are there with just like a relational database and the server hardware that you're running it on. I would say the majority of things aren't like truly big data, that you can run it in like data lake and process it in just a regular SQL instance just fine. The SQL Server instance just fine. But there are occasional like workloads that you'd want to move to it. And I've done that in the past.
Well, I'm just trying to compare it to like my biggest data set is 78 billion rows.
Oh yeah.
And I'm trying to see, because my queries sometimes take, 6, 7, 8 hours to run just for a query. That's not any analytics or anything on top of it. So
yeah, you can also load it into memory, all that data, and then run the query and it'll bring back the results faster. Now, I would also consider their technologies, or you can write functions to like summarize or reduce that data so that you aren't constantly like running all of your queries on that. But you could potentially do that with Apache Spark too, is create your summary data. There are a number of ways that you could approach it, engineering approaches that you can do. I consider Spark as an alternative approach where you can like use that distributed processing power to your advantage and be able to process maybe those data sets, bigger data sets, or query those bigger data sets that you aren't usually able to do.
Okay, thank you.
Yep. Yeah, I'll come up with a good example here in lecture 7. We'll dive into Apache Spark and big data a little bit more. But when you talk about big data, it's not usually just like a million rows. It's like hundreds of millions of rows, or even John says billions of records. Log data can often be like that, generate hundreds of millions or billions of events, especially when you're considering it down to microseconds and everything, generating it every microsecond. Or Internet of Things, like we talked about, that type of data, log data. What else? So Apache Spark pools, they can let you perform big data analytics, the combination of data integration, ETL, Python, and machine learning tasks. So one thing that's also useful in Apache Spark is that you can create an Apache Spark job or notebook, and then you can run that inside of Data Factory. So you can make that part of your data pipeline process. We haven't covered that yet, but you can start using that. You can start using that in some of your processes once you create it. I lost my cursor here. Okay. And developer tools, it's a unified environment for managing and monitoring all of your data related processes. So here's Synapse Analytics. You have Synapse Analytics Studio, which includes data integration. So you actually have data factory inside of Synapse Analytics also. Be able to manage, monitor, and do security. And then you have these processing, these data processing in the cloud. Is your serverless SQL. It's kind of like your storage and data processing in the cloud. Apache Spark and the Data Explorer we saw in the last class. And this is all highly integrated with Data Lake Storage Gen 2. So you can start to see, like, especially with this lecture, like how we're starting to tie like everything we learned together. And usually this is fed in by any combination of data, really. So streaming data, cloud data, on-premises data can be fed into this. And then your output is, PureView is like the data cataloging. We won't cover it really that much in this class, but data catalog and data dictionary tool that Azure has. And then it can be fed to machine learning and Power BI. Those are probably the two most common places that these are fed, because this is really like summarizing and processing it for analytical or machine learning purposes, which is hence the word Azure Synapse Analytics. So another integrated like platform, unified platform to be able to process and store data for analytical purposes. In summary. And we'll go ahead and take a break now, because our second hour will start with Azure Data Factory, which is kind of like the meat and potatoes of this lecture as far as data processing in the cloud that we'll cover in more depth. But this is really like the service that allows you to like create, schedule, and orchestrate the data workflows and move data and transform data. It's kind of like, I consider it like the heavy lifter, the heavy hitter of the data, the Azure data platform. So go ahead and take a break. We'll take like a 10-minute break, come back at 7:25. And in the meantime, during break, I'll play a video here. We'll play a video of Azure Functions. Just do like a getting started video. We'll see how long this video is, and then we'll have everybody come back at that time, but I'll play this during break. Let's do a demo. Videos. See, we'll do one that's not like 30 minutes long. Let's do one that's like how to build serverless Power App, Azure Functions. Power App's kind of interesting because you can, if you know about Microsoft Power App, we don't cover it in this class, but it's like their way to build like little applications or utilities. You can integrate a lot of this stuff with Power Apps. $11.54, this might do it. By Patty Matty. This will give you an example of how they set it up. Monitoring code and output. Yeah, this should be a good video on how to set up Azure Functions, and then how you can monitor it and the code and the output. So we'll run this during break. It's 11 minutes. So we will come back right as this finishes, 7:28. we'll start, and I'll go ahead and put this in its own video so we can watch it during break. See everyone here at 7:28. And if you get a chance, enjoy the Azure Functions video. Go ahead and let's just share that as a window. Okay, we'll go ahead. If you don't hear the sound, let me know.
Are they supposed to be talking?
Oh, did I hear someone? Is it working okay?
No, I can't hear anything, but I don't know if you're supposed to be.
Can't hear it.
No.
Hold on one second. Let me make sure I shared it correctly. Here. Let me try this one more time. Share screen. So I want to just share that as a tab. I may have shared the window last time. I might have done that wrong. Need to find the right tab in all these tabs I have open. So Azure Functions, it can be used to create your own functions in Python and be able to do data extraction tasks, and that's really useful. And then you could orchestrate these with Data Factory. But we can also do that in Synapse Analytics. So, but useful to know about this. So we'll show the video, and I'm still looking for this tab in all my tabs. Hold on. I'm gonna move it. It seems to. Okay. So Azure Functions Demo is the tab that I want to look for. Chrome tag, Azure, okay. This should work. Let's go ahead and play this and make sure that everybody can.
That's why I'm going to create a new research group, and here, this is where you can see.
Does that work?
Yep.
Okay, awesome. I'll play this through, so we'll give ourselves a little bit more time to do like 7:30 coming back from this. Oops, I need to hit the right play button.
Function name, and once you have given the function name, you can choose the this is the function name, this is the code. You can choose. In that situation, you don't get all these details, but let's have a look on the code based, and I'm going to use the .NET code. That's what I'm going to use in the backend. It's going to write in a C# or somewhere, different language with the .NET code, and I can choose a version if I really wanted. And I wanted to choose a region, and post to that within the hosting, you have to choose your storage account, because that's where the queues and other information, that's especially the code, will be saved. So that needs to be provided a storage account. So I'm just giving my newly creating a storage account, and this is where the operating system that you want to use for the runtime stack. So in case if you're choosing as a Windows or Linux, you can be stick to that. So in my case, I'm just sticking to Windows, and the type of the plan that I wanted to use. So in my case, I'm going to actually use serverless with the consumption plan. As we talked earlier, 3 different plans. Like one would be the app service plan and the consumption, which is nothing but a serverless. So there is no infrastructure ready. But with the premium, you have the infrastructure in the backend that will be ready in a warm state. So all the time your infrastructure will be ready. So based on the code, it's going to execute. So that would be a premium. So lesser time to execute the code. So in our case, we are going to use consumption based. And then we'll click on monitoring. This talks about the app insights. Again, if you wanted your functions also to work with the app insights, you can enable that. But in my case, I'm not going to enable because this is just the demo for functions. And you can review and create it, this application. So now it's going to create a application with a name called Paddy Maddy, and that's what the application name it's going to create. So let's click on create. So it can create in a minute or so. I'll just fast forward this video for you. And now the deployment is completed. So I can go to the resource. So as you can see here, it looks very similar to your web applications, the way it looks. But the only difference is it is coming here, functions, and this is where you're going to create a functions. And that's nothing but a simple piece of code that's going to execute for you. And this is the URL for your web application. Very similar to the web application here, it is the URL for your function. So if I wanted to browse, I can actually use this. And there is a small app service plan what got created, which with respect to the functions. This is the app service plan. And now I'm going to actually browse this. That URL. So you see here, this is a function. It is working. As I click on it, it's actually changing the theme color, all that. So it's a working function. It's a simple function that was created by Microsoft for testing this simple web application. That's a function application. Now, as a next step, I'll show you here functions. So you don't have anything called here as the add button. If it's the first time, you might be surprising that you don't have here, but in a minute, I'm going to get it as soon as I develop locally, click on it. So I will be getting that option. So click on that. So you see here, it's activated the plus button add, and you see here, you can use any of these methods like .NET or VS Code or any other editor, and then you can create. So in fact, this is how you can create a code, a function specific project within the Visual Studio. And the pre-requirement is you need to install Visual Studio 2019, ensure that installation is completed. Then you can create a project from a new project, and then choose as the Azure function app, and that can create. So the similar thing, whatever we can do here with these steps in the Visual Studio, that can be actually done with the built-in template also. So I'm going to use that built-in template for us, and then I'm going to create a function. So let's point, this is how the steps to be create, and then I execute your function to test, and then you can publish from your Visual Studio to Azure function app. That being said, let's click on add button, and now I'm going to get a different type of templates. So these are the templates that we talked earlier, like one for HTTP, one for time trigger, and other one would be for the maybe Azure Cosmo DB.
So I should note on this is that Brenda brought up a good point. She said she didn't do all this. So this is a different setup for, it looked like they're setting it up for C# and like integrated with Microsoft Visual Studio. When I did this for Python, it's a lot more straightforward than this setup. I guess it still gives you the idea of you set up like your programming language and your type of machine, like they did a Windows machine, and you set up like your integrated development environment with it, and then you could write code there, and then you could deploy it to an Azure function. And that's the idea, so that you can deploy it, and then you could run it within, you could even run it within Azure Data Factory. So it has an input and an output with this one too, which I believe is data input and output.
Or blob storage or queues. So in our case, we are actually
Just
working
wanted to
with
bring up that
HTTP
point.
trigger. So just select that and click on that, and I'm going to choose here anonymous because I just wanted to browse that without any complexity to show you that web application, how it's going to work. So just I'm taking as the web application since it's the web based. So I wanted to take as anonymous so that I can execute that function by anybody by browsing that URL. So the code has automatically executed and it is readily available for you. The reason being it's just a template. So if you just click on a code and test, now this is our function name and this is one of the functions. So within this function you are enabling or you're working with the code to test it. So I'll just click on code and see how it looks like. So it's going to be C# based with .NET you see here, and this is a simple thing, and the code has been already written. So if I want to test it, just run and test, so that I can run. So here whatever the text you're gonna put it here, that's gonna appear in your browser. That's the web application. So this lecture or this course is not designed for uh, developers exam. So I'm going to actually show you on the infrastructure point of view how this works. So here the code, whatever you put it in Azure or whatever it is, it's going to actually run and show you the code for you. So it's just connecting in the backend. This is where it is actually taking the execution time. So whatever it has taken the execution time, here if you see might be 54 milliseconds example, so that's going to be charged and that's going to be counted for your execution time. So let's see here the code. If you see here the output you're getting is a success with the 200 code, and you got a response saying that hello, and Azure, whatever you have given in the input, that name, and this app trigger functions executed successfully. That's how it's going to give you. So what we will do is we can actually change the Azure name. Instead of that, you can put it something else, and you can run that also. So let's put a value into the input to something else, so that this specific value called Azure gets changed. So let me go down here and click on Azure and give here welcome uh, to maybe a function demo class or something like that, and then run it. So it's going to execute and it gives the output within this output window. Says that hello, welcome to function demo, this has been triggered successfully. What if you want to test it directly on the web browser? Yes, you can do this functionality within the web browser. So all you have to do is just get that function URL and execute it, and this is where you can check the logs actually, and these logs can be stop, query, clear, all that, so that you know what's happening and how many times it has executed. And I'm going to look at the URL based now. So I'll just close the log here and take the copy of that URL, and this is going to function on a default one. So I'll just copy this URL, open a new URL and trigger. So it says that this function is triggered successfully. But what if you have earlier got as Azure or some other query? So how can you do is you can simply put here a question mark name, and whatever the text you are putting here, that's going to be visible here. So you see here it says that welcome to this function demo, and that's how you can put it. So there, from the question and the name equivalent, whatever you put it, that's going to execute. That's about the function with a simple code that we can execute it. So now what we have done is so far we created a function, and within that function um, function app we created, and within that function app we created a small function, and that function is nothing but a small piece of a code which would gives you a serverless infrastructure for you to execute the code on a web browser, and it returns some value. And that's what we have tried with HTTP. And you have deployment slots, you can work very similar the way we worked with the app service plan or web applications. So same thing, you can add your slots and you can swap it if you have additional web slots, so that you can secure your applications. You can move in a staging format from one stage to another stage, like production to maybe a development, or development to UAT to production. All that can be worked here. And authentication, authorization, all these almost the similar things that we have done right with the web application. So same settings will apply here, like the application settings. These are the connections in the backend, and the general settings. You have 32-bit or 64-bit. You can enable the debugging, client request certificate. You can see that whether you want a certificate or not. And for the networking, yes, you have the access restriction, CDN, and front door with the WAF firewall settings, and TLS and SSL settings with private and public key infrastructure. So the concepts are same, and it actually depends if you choose your dynamic scale sets or the scaling plan. That's not what the app plan. So based on that, it's actually executed in my case. So I have this service plan which was created by default. That's why I cannot go for scale up or scale down options. If at all you are using already web app plan for the app service plan, then your functions will work with associated with that app plan. And you can, these are the things that we can talk about the functions app. I hope this lecture is useful for you. Thank you for watching this. We'll catch you in the next lecture.
All right, I'm back. Just wanted to play that during break. It may or may not have been that useful to you, but Azure Functions is really part of like the DevOps, the development portion of Azure. And why there's a lot of, so not only, I think we mentioned in the first class is not only you do use the data platform that's in Azure, but there's this whole part of Azure related to like applications and hosting applications and running it on the cloud. So it's like the whole part. Azure is part of that whole DevOps offering. Yeah, if you remember the data part, it's like a small part of it, and the DevOps is a big part. But you can, hopefully, what you take away is that you configure it, and you're starting to see how you configure these services. And some of them are more involved than others, even though they're still managed. But even with this one, you could potentially like write your own code and create it as a function and trigger it within Azure, which is really useful to be able to deploy for not systems, but also data. Could potentially useful for data too. Probably where you'd use it the most if you have a lot of legacy code or a lot of data pipelines already created in Python, you might just transfer it to Azure Functions and run those functions. But like I said, you can also do this in Synapse Analytics with notebooks. So that's where I go. Well, I actually haven't used functions much at all. So I usually write all the Python and Python code in Synapse Analytics, but useful to show you another potential tool that you have. If you think of yourself as like, what would be a good analogy here? If you were if you were building a house, the more tools you have, the better for the right cases. So I heard somebody say once to me in data that if all you have is a hammer, everything looks like a nail, and you try to solve it all and use it for everything, when you may have some other tools available for you to be able to solve it. So just another tool in the toolbox for the potential use of containerized code and function code, and you could even do containerized code in here, which we won't cover either. But ran that during break, so you could at least be familiar with it. All right, so we'll go ahead, get started with the second hour. Will not be quizzed or anything on Azure Functions. I decided it today as I was going through it that I was borderline on covering it, but I'd rather cover Azure Data Factory and Synapse Analytics for the purpose of our class in depth rather than cover Azure Functions in depth. All right. So just go ahead and share this screen and we'll get going here with hour 2. Keep track of time here. This hour 2 is fairly short because the demo I have is longer today. As you see, we're starting to really like put together all of the different aspects like data lake and processing and output, and then utilizing like storage and database and things like that in these integrated platforms. So the demo's a little bit more involved than the other ones, but I think that's largely the reason why you're starting to connect the dots between these different services. See how they all work together. All right. So getting started with hour 2. So what is Azure Data Factory? We've talked about it a bit already, but it is a cloud-based data integration service that allows you to create, schedule, and orchestrate data workflows. So one of the biggest things in data science is the idea of data pipelines, or these data processes that take your data and ingest it. And then there are a number of steps, just like if you're a process-based thinker, there's a number of steps that you use to transform the data to get it to what you need at the endpoint. So those can be different things, like you could clean the data, you could reduce the data, summarize the data, any number one of the steps. And then one of your steps could be applying a machine learning model or an AI model to it. And that's all part of like your process and pipeline. Why it's really useful now is like, so you don't all have to do all those in small pieces and then orchestrate all that. So orchestrating data is one of the biggest things that you can do with Azure Pipeline. So saying when things should run and what steps should go in that process. Otherwise, it can be, if you write all this Python code or you don't have this, the bigger it gets, the harder it can be to orchestrate all these data workflows together. And that actually can become a pretty big mess. So Azure Data Factory is a way of handling that. So ADF works to move, transform, and map data from various solutions within Microsoft Azure and externally. So what I mean by externally is that you can connect to REST APIs, you can connect to on-premises servers that we talked about that are outside of the cloud. You could connect to other cloud storage like Google Drive, any number of things that are even outside of Microsoft Azure. If there's an integration that Microsoft has, or you could even write your own custom integrations with Python or something to be able to get that data. So it's a really flexible tool to move, transform, and map data from almost any type of system. Provides a visual interface where you can drag and drop elements and create and manage data integration pipelines. This whole idea of drag and drop is really big. It's mentioned a few seconds ago about writing code. Now, when you have drag and drop, you don't have to write so much code. You have like little functions that you can drop in and connect to each other. So it's like visual code, so you don't have to write your own code. I'm always big about like low code or no code platforms, because the less code that you write means the less code you have to maintain and update and monitor. So it's huge to be able to use a visual interface, and it can simplify things, especially if that workflow gets complicated, and sometimes it does. It supports numerous built-in connectors. Just mentioning these: Azure SQL databases, Cosmos, SAP, and Salesforce. So these are like CRM systems that are outside of their external systems outside of Azure, and even Oracle or SQL Server on-prem. We'll take a look at some of those. So 5 of the main features of Azure Data Factory, going from we'll go from bottom to top here, not really in order. But data integration, integrating data from various sources, very important, especially if you have an organization with literally hundreds or thousands of various sources. It'd be almost impossible for one person to do that. With Data Factory, it makes it at least more possible for one person to do that. Data orchestration, so orchestrating complex workflows for data processing. Timing can be big, or the order of things that are processed can be a huge deal. This platform makes it easier to do that. Moving data, that can't be underestimated, the effort that's there, especially if you're like John and you have to move billions of records, a file that's like terabytes in size. Efficiently moving between on-premises and cloud environments, or between different services or systems big. One of the biggest parts of business intelligence really is just engineering the movement of data from one system or one network to another. Data transformation, so being able to put in those transformations, whether it's ETL or ELT, to enrich data to meet business requirements. In monitoring and managing data. So said one of the roles of data engineer is to be able to monitor and manage the systems and improve performance. Azure Data Factory gives you some of those tools to do that. Many of the tools to do that. So real world ADF applications, Azure Data Factory. So kind of, once again, the why Azure Data Factory helps with efficiency of those ETL or ELT processes, which leads to improved data warehousing. One of the big things is Azure Data Factory will help centralize like all those pipelines and rules that you create. One thing I've run into the past is writing just like Python program after Python program after Python script, and they aren't like all centralized, and then you don't know like what's the right version or what's running, keeping track of what's running when, or what rules are you wrote in one Python in one piece of code versus another piece of code. This is like a whole centralization for all of the data and the business rules and the code around it. It's huge in that Data Factory pipelines. It all brings it into one platform in one place, so it's easier to manage. Big data processing, so handling and analyzing large volumes of data. So you can use Azure Data Factory does a good job of it itself because of scalable resources, but you can also use it alongside like HD Insight or Stream Analytics and include that, or Azure Synapse Analytics, include those in workflows. In IoT, data ingestion, integration of Internet of Things data streams. So I think we saw an example of using Stream Analytics there on IoT, where you started to place it in the data lake. You can create that stream process and use that in Data Factory. All right. So the core components of Azure Data Factory, I think I meant to put a graphic here of some type, but the core components, so we're going to look at these in detail here in a second. I think this is a video, so I'll back out of this here in a second. But the core components of Azure Data Factory, and we're going to see like a demo of this, is that you have your data store. So the repositories that hold data used by Azure Data Factory. In Azure, that's almost exclusively the Gen 2 data lake storage. And then you have link services, so you connect to external sources or destinations. So this is where you're going to define all those Azure services or external services that you want to connect to. So you're defining the connections that you're connecting Azure Data Factory to. Then you define your data sets. So these are the data structures within Data Factory. So once you have a link service, say you have a link service to MySQL database, then you could connect to one of the tables as a data set. So you define your link service, then you can define your data sets from your link service. So we've talked about pipelines, being able to orchestrate and automate movement, data movement and transformation. We'll see this in action. Your activities are the things that you place in your data workflow, like your operations or your functions, to be able to do stuff like copying data or transforming data. Oh, there are a whole bunch of other ones. Also, I mean, copy data is what I use the most, but there's also ones where you could, link service would be, REST API would be a link service. But you could do Spark job or a machine learning job or something like that in the pipeline on data. All right, so triggers, they define the actions performed on the data. With pipelines, you set triggers for when you want them to run, or like what condition, time of the day, or what conditions are met. And then you can generate alerts to proactively monitor your data pipelines. So let's see if I have a video here. I'm pretty sure I do. So I'm gonna bring up PowerPoint. This one is a little bit longer, but this one is also important to show. This is about 15 minutes long. But we're near the end of the lecture. So
hi friends, welcome to Azure Content. This is part 5.
Let me get the link for this and then we can focus in on it. But this is a really good just like walkthrough of Azure Data Factory and all these components that we talked about in an example. Let's see. Copy video URL. So stop the screen share for a second so I can share that tab. There used to be. Facebook's also becoming like unbearable too. I'm old enough for Facebook. That's what my daughters told me. They're like, you just need to move to other stuff. There's like more and more advertisements on these things, like every 3 minutes. Seems like we're 5 minutes on YouTube. Oh, well, there's still a lot of good stuff on YouTube, especially like this. Okay. Just being old and complaining. Being an old grumpy guy. Not that old, but being a grumpy guy for sure. Back in the day, they only had commercials on TV, but even those were annoying, right? Because the volume
changed, yeah.
it turned up like 3 times, whatever. Okay, we're sharing this. Everybody on the video feed, let me know if you can or can't hear it. I should have just played that in the background.
We get remote monitoring and management.
We can hear it.
Hi friends, Content.
Can you hear it?
This is part 5 in Azure Data Factory playlist.
Yep.
In this video, we are going to learn what are the key components of Azure Data Factory.
Awesome.
So if you want to work with ADF and if you want ADF to perform your ETL or ELT job, then you need to have a basic understanding of all these key concepts.
15 minutes, we still have time in class, but this is really good. This is really good walkthrough and breaking it down into all these things that we just talked about. So you know how to use Data Factory. So we'll play this for the next 19 minutes.
The basic key components of ADF, which includes activities, pipelines, linked services, datasets, data flows, integration runtime, and triggers. So we will try to understand each of these components in detail one by one in this video. Okay. So moving on to the first component. So first of all, what are activities? So by definition, activities represents a processing step in a pipeline. So you can think of an activity as a single step in a pipeline or a single unit of task in a pipeline. If we combine multiple activities together, then it will create a meaningful pipeline for you. So basically, activity is a building block of the pipeline. By combining these activities in a meaningful way, we can perform certain tasks in ADF. For example, you might use a copy activity to copy data from one data store to another data store.
All that.
So we have multiple activities in ADF. You can use these activities as per your requirement. So if you want to copy certain data, then you can use copy activity to move the data from one data store to another data store. So copy activity is one such activity that helps you to perform data movement. So if we see from the top level, Data Factory supports 3 types of activities. First one is data movement activities, then data transformation activities, and third one is control flow activities. So coming to the first categories of activities, we have copy data activity to perform data movement from certain data store to another data stores. Okay, so from source to sink, if we want to copy some data, we have to use copy data activity. Okay, apart from copy data activity, we can also make use of data flow activity to load the data from source to sink. Okay, but majorly data flow is used to perform data transformation. So in ADF, data flow is called the data transformation tool, but you can just think that to perform data movement, we can use copy data activity or we can use data flow activity. Now coming to data transformation activities. So we have lots of activities which helps us to transform the data as per the requirement. So you can see the whole list of data transformation activities here. So few of them are used to deal with the big data technologies. For example, HD Insights, Hive activity, MapReduce. So these are used to work with big data technology. You can also work with Spark technology with the help of Databricks notebooks or HD Insight Spark activity. So there are many activities. We will learn few of them in details later. Then there comes control flow activities, which we will use most often. These are the activities which helps us to provide logic into the pipeline. For example, append variable, execute pipeline for each activity, if condition we have, and then switch activity we have. So all these kinds of activities are called control flow activities, which basically helps to control the workflow of pipeline. So basically in total, we have around 40 activities. We will see the functionalities of these activities in details in upcoming videos. So I hope you got a certain idea of what activities are and what they do in ADF. Now moving on to the next slide. So what are pipelines now? As we discussed, pipelines are the logical grouping of activities that perform a unit of work. So pipelines are basically the combination of multiple activities, but a simple pipeline can also be created with the help of a single activity. Basically, we can say pipelines are the set of activities which perform a certain task. So together, the activities in a pipeline perform a certain task. The activities in a pipeline can be chained together to operate sequentially, or they can operate independently in parallel. So there are multiple ways in which you can group these activities. You need to think about the requirement. So based on the requirement, you need to perform these groupings. So suppose if there are two activities which are not dependent on each other, then you can run them in parallel. If there is no dependency, then you don't need to connect in series. So once these two activities finish their job, then you want to run another activity. Then you have to connect it with both of them in series. Okay. Or if you have a requirement like this copy activity, and once this copy activity is finished, so suppose once the data is loaded in ADLS, you want to run a Power Query, and also you want to run a SQL query using script activity, and these two do not have any dependency on each other, then you can run them in parallel. And once both of them are finished, that means the whole pipeline is finished, then I want to run a web activity that will trigger the email notification that the pipeline is completed. So you can group the activities together in a meaningful way based on the requirement. Whenever we create the ADF pipeline, our motto is to have as less number of activities as possible, so that we can perform a certain task in the most optimized way. So one important information here is, in ADF, the maximum number of pipelines that you can create is 40. So if you have a requirement to create more number of pipelines, you need to create another ADF workspace itself. So 40 is the maximum number of limits for pipelines in an ADF. So before moving to the next components, let me show you how
Uh, 5-minute commercial.
Managed WordPress hosting by Hostinger. Here are 3 super features to improve your website performance.
how does an in ADF. So let me go to ADF portal. So you can see in ADF, we are currently in the author menu. If I expand this, you can see there is home, author, monitor, manage, and learning center. We have already covered each and every menu in details in our previous videos in part 2. So I would recommend you to watch the videos in series in the playlist. Okay. So if you see in the author menu, we have the option to create pipelines. Okay. Either I can go ahead and click on this new pipeline option, or I can click on this plus option where I have multiple options to create other resources as well. So I can go ahead and click on this pipeline option to create a new pipeline. Okay. And inside this, you can see we have lots of categories of activities. So we have move and transform, inside which we have copy data activity and data flow activity. Okay. And then we have synapse. Inside that, we have notebook and Spark job definition. So these are the activities which will help us to create the pipeline. Okay, you can see each of them by expanding these. I'm not going into much details. So how do we create the pipeline? We can simply drag these activities, whatever is needed, into the white canvas present here. So suppose I'm trying to copy the data from some REST API to SQL database. So what I need to do is we need to create some connection to that REST API, and we need to provide the details of that source dataset here. And then we need to provide the details of the SQL server here in the sync dataset. And once this execution is finished, I want to run some notebook, Databricks notebook. So I will connect these two activities in series. And suppose I also want to run Hive query. So I will go to SD Insights and I will drag this Hive query and I will run these two in parallel because they do not have any dependency on each other. So suppose once these two activities executed successfully, then I want to send an email notification saying that the pipeline executed successfully. So for that, I can use a web activity after these notebook and Hive query to run this web activity that will send the email notification. So this is how our pipeline would look like. So individually, these tasks or these icons are called activities, and together once they are combined, it is called a pipeline. So I can then debug these pipelines, or I can also create a trigger so that it will be running on a schedule basis or based on some event. So we will see those things in details later. Now going back again to the presentation. So I hope you got a little idea of what activities are and what pipelines are. Now moving ahead. So what are linked services? Linked services are much like connection strings, which define the connection information that's needed for Data Factory to connect to external resources. So basically, linked services are the components which store the connection details of any data store. So for example, if I want to connect with a SQL database, then linked service is the place where I'll be storing all the connection related information. For example, server name and database name, then user ID, then password. All this information I will have to store in the linked service so that it will be able to connect to the SQL server in ADF pipeline. So we will see how to create a linked service and how linked services looks like. So we will see that in practical in just few minutes. So before doing that, let me talk about datasets. So what are datasets? Datasets represent data structure within the data store, which points to the data which you want to use in activities as inputs or outputs. Basically, datasets are the reference points to any data store. So just to understand, datasets are like a wrapper resource on top of a linked service. So you can think of it in this way. Linked service defines the connection to the data store, and dataset represents the structure of the data. So for example, if we have a linked service pointing to Azure storage, then the link service will hold the connection related information pointing to the Azure storage. Okay. So for example, it can have the URL pointing to the storage account, and it can have the account key that will be helpful to connect to the storage account. So once this link service is created, we can create a dataset on top of this link service. So dataset will hold the information like inside this storage account, which particular folder or which particular file I want to point to inside which container of this storage account. Okay. So don't get confused. Let me go to the Azure portal and show you practically how does the link service and how does the dataset looks like. Okay. So once you go to the Manage tab, you have the ability to create the link service here in the connection menu. Okay. So I can create a new link service and I can select the data store, for example, Azure Blob Storage. Okay. So here I need to provide the subscription details and the storage account name in order to create the link service. Or we can also enter manually all the details. Okay. So if I select my subscription and let me select the storage account name, so I'll be able to create the link service here. So you can see connection is successful and I can create the link service by clicking on this create option. So it has successfully created the link service for me. Now, if I go to this JSON option, you can see all these connection related information are present, to which account this link service points to and what are the credential. So this is the encrypted credential over it. Okay. Now, if I want to create a data set, I need to go to the author menu, and here I need to click on this plus and then dataset option. Again, I need to select the kind of storage on which I want to create my dataset. So since I want to point to blob storage, I will select the blob storage itself. And if I click on continue, I need to select the type of data I have in my blob storage. So suppose I'm selecting CSV format. So as we discussed, dataset is nothing but the wrapper resource on top of the link service. So we need to select link service on top of which we need to create this dataset. So I have created this ls_blob pointing to the blob storage. So once I select that, you can see I can navigate to the file or folder to which I want my dataset to point to. Okay. So I can browse here and I can select the folder, or I can go inside the folder and select a particular file. So suppose if I want to copy only a certain file, then I will select a file present here and I will click on OK, and it will create a dataset pointing to this file. Okay. So I can go ahead and select this
Video.
delimited text 42
I don't remember that watching
from the list of datasets present inside my ADF or SQL database. Okay, so I already have a dataset. So I'll be just selecting it. So this is how the SQL database dataset looks like, and it is pointing to a link service, okay, which holds the connection related information for my SQL database. Okay, so you can see this is the server name, then database name, and SQL authentication is the authentication type, and it has the username and password. So this is how you can create link service and dataset. So basically, link service and dataset are having many to one.
Hey tech leads, this is Monday Dev, a platform to manage your entire product development lifecycle to connect everyone you work with. With Monday Dev, you have a view of everything. You can connect with all your team members in any department and stay aligned on feature requests, product roadmaps, bugs queue, and more. And everything is easily customizable. You can add a column, drag and drop it here, change your story point.
And relationship. That means we can create multiple datasets on top of link service. Okay, so we can create multiple datasets on top of one link service, but we cannot point to multiple link service from one dataset.
Everybody can still hear me, okay?
So this is not possible, but this way it is possible, which means on top of a link service, we can create multiple datasets. So dataset to link service is many to one relationship. Okay.
We're going to take the.
So what I'm trying to say is, let me go to Manage tab.
Loaded.
So you can see I have a link service called ds_ADLS, okay, which has 52 datasets associated with it. Okay. So you can see multiple datasets can be created on top of one link service itself. Okay.
Than her workflow,
but if I go to a particular dataset, if I open any such data set, so here you can see we have an option to select only one linked service in a data set. So basically we can create multiple data sets pointing to a single linked service. That's what I want to convey. So now let me go back to the presentation. So I hope you got a little bit idea of what linked service and data sets are. Now moving on to the next slide. What is integration runtime? So in Data Factory, an activity defines the action to be performed. A linked service defines the connection details of a data store. And an integration runtime, suppose if I want to move the data from one data store to another data store, and for that I'm using a copy data activity which holds the connection related information for source and sink. Okay, so it has all the connection details which is present in the linked service. But in order to perform this data movement, we need some kind of machine, right? So that machine is nothing but this integration runtime. So integration runtime is the compute infrastructure used by ADF to provide various data integration capabilities across different network environments.
There are a bunch
so we
of
can
these.
create. Then there is Azure.
Companies used for ETL SQL Server integration services, and that's how you can connect these legacy pipelines to Azure that you created from like an on-premises system. And then they'll show you that, and then triggers.
A unit of processing that determines when a pipeline execution needs to be kicked off. Basically, triggers are the scheduler for our pipelines. Okay.
The pipeline.
So we can schedule our pipelines with the help of these triggers. So either we can schedule it on the databases, we can schedule it based on, so on the arrival of the file, trigger that is scheduled are created. So inside this manage tab, in author menu, you can go to create a new trigger. So you can see we have 4 kinds of trigger, that is schedule trigger, tumbling window trigger, storage events, and custom events triggers. Okay, so we will learn these things in details in upcoming videos. So for now, we just understood what are the basic components of ADF, which we need to understand in order to create our ETL workflow. So that's it for this video, guys. I hope you like the content. Please like the video and please subscribe to my channel if you haven't done it yet. Thank you.
Hey, got a second? I'm going to show you how I got the flexibility to...
Audio failed us there. So I'll go ahead and finish up my last slide, and then we'll do the last guided exercise together. All right, share screen. Okay. There are all the core components with demo and how it works in action in Data Factory. Yeah. So the last slide I have is I wanted to bring up another point about monitoring and management in ADF and Azure Data Factory. One of the big
we
parts.
can't see your
Said
slides.
it a few times in this lecture, but oops, I forgot to hit share, didn't I? Thank you. Thanks for catching me before I got too far there. So efficient monitoring and management in Azure Data Factory. Said it a few times in the lecture. This is like one of the biggest parts about being a data engineer is monitoring the system and being able to manage it, improve management. So ADF has comprehensive monitoring. There's actually within Azure Data Factory, there are monitor and manage tools for tracking pipeline performance. So it'll look like something like this. You'll have all your pipeline runs in the last 24 hours. You can see when it started and the duration, whether it failed or succeeded, and you can even get the error messages out of it. So huge if you have issues to be able to track them down and see how long things also run and what's a potential bottleneck. Workflow management, you can leverage dashboards to efficiently manage data workflows. They have a series of dashboards in here that allow you to take a look at different metrics. I found working with systems, that's sometimes the only way I could wrap my head around things, is like I have to have data and visuals to tell me like how many processes ran and failed and where to look, and what times they ran. Even within a system I worked in, like how much CPU and memory certain processors were taking up, because that could tell you if the process you've created is efficient or inefficient, and if you need to go back and do something about it. And alert triggering capabilities, this is one of the biggest. So you saw in that last demo where they made the connector to the web, and then it would send an email whether it's like successful or unsuccessful in the job name. That's huge to just have that alert you, instead of having to like scroll through like all the different pipelines. You can just have it come to your email, like almost all database administrators do something like that. If it's critical enough, I've seen where you can do the pipelines to just send you an SMS on your phone. So like the super critical, mission critical ones, you could potentially just have it sent to your phone, and you can get and fix it as soon as possible. So the life of the IT person, or somebody who's systems engineer, systems analyst, or data engineer, is that you're on alert, but you're trying to make things as easy or efficient as possible for yourself instead of harder for yourself. I would say easier for yourself, but some of it's like trying to not make things harder on yourself. I would say that, especially at scale, when things get bigger and bigger and harder to just manually check or do a certain way. It is an aid to help you really. Okay. So I also didn't fill out all the additional resources. I owe everyone resources for this class and the last class. There is a good one on Azure Stream Analytics here. It was a walkthrough and a basic tutorial. And there's another one of creating triggers to monitor data pipelines. All right. So a recap, we cover a lot of ground in these classes early. It's like like I said, a matter of what do we cover at a higher level versus we go in depth. I think Azure Data Factory was definitely a good one to go into depth as far as this is really like the life of a data engineer, is like creating these pipelines and processing this data. We went through the core components of Azure Data Factory. There are a lot of tools